y'all, happy Monday. Today we're going to be learning about word problems, turning word problems into linear equations, and then solving those linear equations and using them and that type of stuff, maybe some graphing. Before we get started, I wanted to tell you a little bit about my weekend. So this weekend I was laying outside by my, just behind my apartment because my pool's closed for COVID-19. So I was laying out. Is that a turtle? Okay, sorry, I was distracted by the turtle. So I was laying outside by my, this little lake behind my apartment, and I brought down a book and I was gonna get a tan, and I saw this sign that said, "Please don't feed the alligator." And I was like, should I be concerned? I've never seen an alligator here before, but I don't know, I'm a little bit worried now. And so as I was sitting there, I was thinking, how big is this lake, and am I going to see an alligator? And if I did see an alligator, what's my best course of action of where to run? And I thought of this math problem that we're going to do today about the alligator and my tanning situation. Before I do the alligator problem, I want to start you off with something just a little bit easier. So check out this problem. Miss Reeb went to the fair. It costed $12 to get in and an additional $1.50 per ride. How much did she spend if she went on 3 rides? So if we look at this problem, we can figure out our initial value, our rate, what our x stands for, what our y stands for, and maybe we can put it on a graph that helps us to visualize. So let's take a look. It costed $12 to get in. So if I want to go to the fair, I have to pay this $12 no matter how many rides I go on. It's not dependent on the number of rides. So I know that $12, because it's not dependent on the number of rides I go on, is a constant. And I know that our constant value is our b value in our equation, y equals mx plus b. This b is our 12. So this m in y equals mx plus b is related to the x. So I need to figure out, first of all, what does the x stand for? And second of all, what part is related to the x? And to get that, I'm going to use my units. So I know that my b is my initial cost. So that means that our y values are going to have to do with money. And I know that because our constant is our y-intercept. So our y-intercept, or our line crosses the y-axis at 12. And that means that all of our y values have to do with money. Money in dollars. So now I need to figure out what my x value is going to be based on my units. So Miss Reed went to the fair, it cost $12 to get in, and an additional $1.50 per ride. So see this word per? This word per means that we have a rate going on. That means that rides are going to be our x value. So our x value is rides. And this $1.50 per ride is a rate. And our rate, because it is per ride, it is dependent on how many rides they go on. So our m value is $1.50. Our m value is 1.5. So now I'm going to plug these into my equation. Y equals 1.5x plus 12. Y equals 1.5x plus 12. Or the total cost equals $1.50 per ride plus the $12 that it costed me to get in. So now if I want to find out how much did she spend if she went went on 3 rides, I'm going to plug this 3 in for x. So y equals 1.5 times 3 plus 12. And now I can solve through using PEMDAS. And I already know that my y values are money in dollars. So I spent $16.50. Miss Reeb was tanning outside her apartment. An alligator spotted her from 34 feet away. It started swimming towards her at a rate of 1/2 feet per second. How long will it take for the gator to eat Miss Reeb and eat her for lunch? So obviously this gator didn't eat me for lunch because I'm still here to teach you math, but we are going to go through this word problem piece by piece. So the first thing I want to point out is that this alligator is 34 feet away from Miss Reeb. Now my alligator doesn't look great. I'm not an artist, and also, like I said, I've never actually seen an alligator, so I just kind of guessed what it would look like. So this alligator is 34 feet away from me. That's going to be important in a minute. So this alligator is 34 feet away. Now this 34 is a constant number, and I know it's a constant because its unit is constant. It's just in feet. So in our equation, y equals mx plus b, this b is also a constant. So I know my 34 feet is going to be my b. So I will plug in b equals 34. My next sentence says, it started swimming towards her at a rate of 1/2 feet per second. Now I see 2 clue words here. The word rate gives away that this is going to be a rate. Also the units, feet per second. This unit is written as a fraction, so that also tells me this is going to be a rate. 1/2 feet per second is our rate. And our rate is going to be connected to our x value, because a rate implies that these 2 terms are doing something with each other. So that means that our rate, 1/2, is our m value. So our m value is 1/2. But I want to be specific because this says that the alligator started swimming towards me, Miss Reeb, at a rate of 1/2 feet per second. So if this alligator is swimming towards me, I'm kind of like the starting point. So me, Miss Reeb, I am 0. And if this alligator is moving towards 0, we're actually going negative 1/2 feet per second. And that's going to be important in a minute. So I'm going to plug in the values that I know into my formula. So y equals negative 1/2 x plus 34. And now we have an equation. And we can use this equation to solve how long will it take for the gator to reach Miss Reeb and eat her for lunch. So this is where we're going to use a graph and our units to work together to figure out where the gator reaching Miss Reeb, where that's going to get plugged into so we can solve this equation. So if I bring it to my graph here, right, this is my y-axis, this is my x-axis. So on my b is my y-intercept, and the y-intercept obviously falls on the y-axis. So this 34 will fall on the y-axis. And because this 34 falls on the y-axis, that means that y is feet from Miss Reeb. And that implies that this 0 right here, when you are 0 feet away from Miss Reed, you are on top of Miss Reed. So I'm looking for where this alligator is on top of Miss Reed, or where it is 0 feet away from Miss Reed. So that means we're going to plug in a 0 for our y. 0 equals negative 1/2 x plus 34. And now that we figured out what to plug in and where to plug it in, we're just going to solve for x. So I'll do the inverse operations to move 34 to the other side. So I end up with negative 34 equals negative 1/2 x. Now if I want to get x by itself, I'm going to use inverse operations. The opposite of multiplying by a fraction is multiplying by a whole number. So I'm going to multiply by negative 2. And I'm multiplying by negative 2 because this is a negative 1/2. Multiply by negative 2. So I end up with positive 68 equals x. I want to take it back to the units for a minute and figure out what my units are going to be. So in my rate was negative 1/2 feet per second. Well, we've already covered that the feet are our y values, so that means that seconds are going to be our x values or our x units. And also we can get this from our problem where it says how long will it take, so we know that it's going to be a time value. So 68 seconds. So if I spot an alligator, I have 68 seconds before I need to start running, or it is going to eat me for lunch. That's it for today. Make sure that you do your practice problems on quizzes, and then you do your exit ticket on Flipgrid. If you have any questions, you can email me, you can send me an Edmodo message. I answer my emails and Edmodo messages between 8:30 and 3:30, so you can message me on there and I will get back to you, or you can set up a Zoom meeting if you would like one. Leave me a comment in the comment section below about what you did this weekend.